Hello and welcome back to the Fullerton College Pre-Press class. This is Ben Hewitt, your instructor. We're going to continue on with PIA's Pre-Press Training Manual, Section 3.3 on Digital File Types. Today we're going to look into a bit more specifically what exact files are likely to be encountered out there and what you should expect from them. This is similar to some of the stuff we talked about back in 1.3 Digital File Basics. So we're going to look at the common file formats found in desktop publishing and how to recognize them by their extensions. These, except for the bottom one, this list here, InDesign, QuarkXPress, Illustrator, Photoshop, native files, those are all native file documents that are opened by the actual graphics program. I kind of wish JPEG didn't end up on the same page because it's a different type of file. Because the first four up there are all files that can be edited and changed and completely redone within their respective programs. The last one, once you've made a JPEG, it's a JPEG. There's nothing more you can do it other than manipulate its pixels individually in Photoshop. There's other types. See, actually, if I was going to redo this thing, JPEG should have been on this page because it belongs to the other types of image files seen here. And in fact, EPS and PDF should be a separate page. But we'll get into that. So a TIFF or TIFF, depending on if your computer is supporting 4-digit extensions or only 3-character extensions, the tagged image file format. This was Apple's attempt to make the ultimate raster image file in the late 80s and early 90s to make the perfect digital photograph, the one that was going to be the standard for computing because it had the highest quality type of image you can get, the best color support, the most information per pixel. They're larger than other files because there's no compression, although there is a certain type of very minor indexing compression that can be done that gets talked about in another part of our class. But overall, your impression of a TIFF should be, this is the most pure, literal pixel image, where the computer remembers, depending on how much memory is given to each pixel to the color depth and information, however much memory is there, it knows within that accuracy exactly what color each tile is in the giant mosaic that is the raster image. And how many tiles are there? Well, that depends on the original photograph taken. But there are no shortcuts. There are no computer mnemonic devices that change how it goes. It is literally the data from the sensor, be it a scanner or a camera, literally transposed in front of you in its little grid. No changes. The .bmp, I've already made my tank joke in the previous chapter, the 1.3, so refer back there, chuckle again about the Soviet armored personnel carrier with the same name, but the .bmp was the Windows version of the TIFF, because at the time, Windows and Mac were not so simpatico like they are now, and they certainly didn't both share the Linux backend like they do now. And it was much harder for any sort of file at all to cross the uncrossable rift, that great divide that was the difference between your operating systems. So they had their own version of a more basic, what you see is what you get, no compression, no funny business, no police, no Batman. Wait, that's my deal tonight at the docks. But you know what I mean. A very basic, but very high quality raster image where you just see pixels as they were captured by its sensor and as they were saved. No compression, no changes, no shortcuts. The TIFF is better. In fact, the BMP has all but died off, and the TIFF is now used on both systems as a better image. Try to get those when you can. PNGs, portable network graphics. The name should tell you all you need to know, and we'll go into more details. It's meant for the interwebs. It's not meant for print. It gets used for printing sometimes because to a lot of clients, a digital picture is a digital picture, and they're not too savvy about the differences. That's our job. The EPS is the encapsulated postscript. Again, this is a file that remembers what data was going to be sent to a printer or would be sent to a printer if you sent it off to print. But instead it saves as a file type that can be reopened on a computer. It used to be the best, most stable, most accurate output file for a print job that was being created in desktop publishing. But that was before the coming of the PDF. Oh, PDF, how we love you. So let's go in a little more detail on these. InDesign document. I emphasize the in and InDesign just to annoy Orson Welles there a little bit, because you can't start a word with in and emphasize it. It's impossible. I won't do it. So Adobe's InDesign, this was a big game changer for me. It took a lot of the headache away. And I don't mean to say horrible things about QuarkXPress because it is a good program, but it was also the first real widely adopted, widespreadly used desktop publishing layout system. And the kinks hasn't been worked out, and UX wasn't a consideration at all. InDesign kind of took the same concept and made it convenient, because people already liked Photoshop. Photoshop, much by accident, came out with a pretty good UX. And then they've improved it since, of course, as they have with everything. But the type of user interface that people loved about Photoshop got applied to QuarkXPress, and that gives you InDesign. Don't forget, and maybe you need to refer back to that video from 1.3 of the lonely mouse singing lonely songs to the moon, because an InDesign document by itself is like a lost child. It needs its family. It's not going to make it on its own. The InDesign native file contains all the information for the computer to know what fonts to use, where to put your pictures, and what pages and what size everything is. It does not contain the fonts themselves or the pictures themselves. Without these linked files and without the supportive font files, this thing is useless. It needs to come by itself. Remember, an InDesign file on its own is an unaccompanied minor, like finding a 3-year-old wandering a grocery store by him or herself. You need to help that little guy out and find his or her parents, because really, they shouldn't be alone wandering the grocery store. And that's how those types of native files work. Similarly, QuarkXPress documents also don't work on their own in a vacuum. They require the support of linked images and linked, fonts. Without those, it is just a directory file telling the computer where to put things, but without the things, it doesn't work. This is like when I was younger and I learned how to budget my money, and I didn't have any money. So whatever budget plans I worked out, whatever financial things I had trying to go, when you don't have anything to budget, your budget is a great idea, but without the money to fill it out, it's kind of useless. Yet again, another example of the page layout software document without the things that it's laying out. It needs those supporting files. But it should also mention that graphics created in the Quark are vector, as is the same with InDesign. .ai, I love these. Illustrators. These are a little bit wonky sometimes, just because they can, if the artist used raster images in their AI file and did not embed them, you could find yourself needing a supporting linked file to be able to make proper edits. If they use fonts that are not outlined, you still have to deal with the problem of missing fonts. Otherwise, AI files are almost always good to go. You get an AI file, it should be ready to run. You can also link them directly into InDesign files and into QuarkXPress nowadays. And I believe you can even import them as a layer into Photoshop as either a kind of a, what do they call it? A vector, shoot, I can't remember the name of it. Now I'm going to sound like I don't know anything, but I can't recall off the top of my head. I can look it up. Yes, they call it the Vector Smart Object. And the Vector Smart Object is basically a linked file in Photoshop, because Photoshop won't really touch it the way it touches other things. It won't rasterize it, you won't manipulate its pixels, but it'll be present in the Photoshop document within the layers. This can be useful if you want to include a logo and be able to make changes to it the same way you would do in InDesign, you can do in Photoshop. But don't try to typeset a page of text in Photoshop. It's not great. It's doable, but it's not great. Speaking of Photoshop, are your ears burning Photoshop? The PSD is the Photoshop format. The default file format, the PSD supports layers. The PSD supports transparency and raster effects. The PSD supports, like we talked about with the meta files, it supports some limited vector graphics embedded in it, be it as Vector Smart Object or a clipping mask. You go, Photoshop. Also, you're able to put amount of bits per channel in dynamic ranges. This is meaning you're able to choose how much memory the computer is going to give per channel of color within your image. That means for every pixel, how much memory is being dedicated to remembering the exact level of red light, green light, and blue light that is mixed to make the color that you see. 32 bits is much better than 16 bits, and it's not double the goodness, it's exponentially better. And 64 bits, which is now available, is definitely better for color accuracy. Unfortunately, when you start putting this many bits per channel, per pixel on your screen, it starts to take quite a bit of computer resource to remember all of that information. So the cost, I know I'm a few years behind on this one. If anybody watched that Once Upon a Time show, magic always has a price, dearie. there is a cost to color perfection, and that is file size and computer memory, which also turns into processing time. So sometimes it's worth it to get the color almost right to have it process a heck of a lot faster, depending on the system you're going to. And if you send it to someone with an older computer and you try to throw them a 64-bit color system out of the latest version of Photoshop, you are going to crash that poor sod. Anyways, moving on. JPEG. I'm going to include a secondary video on this one because I want you to see what this is. So I'm going to, after I'm done talking about this slide, we're going to end this section, and there's going to be a secondary video. So scroll down in your canvas there and take a look at it, because I want you to see what JPEG is actually doing. All right. The JPEG format supports CMYK, RGB, and grayscale, but does not support alpha channels. It's too bad. The real problem is that the JPEG is lossy compression file format. This is not as good on a video as it is in person, but I actually grew up down the street and was neighbors and friends with a family of one of the people who was on the Joint Photographic Experts group. He represented Canon, and they worked at Caltech in Pasadena, just a few blocks from where I grew up. We used to walk the streets with them and their kids when I was like 2 years old. We're still friends with them, cool guys. But anyways, the Joint Photographic Experts group was a group of scientists and engineers from different companies around the world, including Canon, Xerox, Adobe, Apple, I think Microsoft, and a bunch of other groups who came together to create a more easily savable file format for the, at the time, budding industry of digital photography. And they found ways of cutting corners, quite literally, to make it work with less memory and less time. It works by not remembering all the details. It works by forgetting, conveniently, based off different mathematical algorithms, parts of an image so that it only shows you some of it, enough to trigger you, the human, to respond that this is the same picture, but without being as precise as a TIFF or BMP, which would have shown you literally every pixel. JPEG, for shorthand, kind of shows you the average colors and the average pixel changes within a region. And we'll look at that in a moment on the attached video. I should also mention that the reason the JPEG has taken over such a huge portion of digital imagery is because of the internet. Because remember the early days. If you don't, let me tell you about the early days again. The internet was not always fast. I know you may complain about how slow things feel right now, but I was there from the beginning when Al Gore first invented it. I'm pausing so you guys can laugh because I'm a funny guy. Anyways, from the very beginning, the internet used phone lines, which don't have the bandwidth. And phone lines are basically a slightly upgraded telegraph line, and a telegraph line only sends a single pulse. The off or on, a little switch they spark while they tap, tap, tap out the different messages to each other. Anyways, JPEGs being smaller transferred faster on early networks and were easier to send across the internet. This let there be pictures on the internet instead of just text, and let people go around and browse pictures of cats doing funny things. Because after all, that's why we built the internet, isn't it?